welcome back. First thing first, we have a new team member, Chris Gerber. So some of you probably already heard from him as he being your point person, but he's here to help. Second, don't forget that your project is due next Wednesday. So we are diving into iOS / Objective-C today, but you still need to keep up with your project that still has to do with JavaScript and HTML. Okay, so first we're going to recommend some books. David always recommends this one. You're going to want to make sure that your book is up to date with all the new iOS versions. So iOS 7, it was a very recent development. We are only going to be dealing with iOS 6, plus I think iOS 7 isn't like officially available for a couple months. So iOS 6 is what you're going to want to be using. When you start going back versions of iOS, things start changing pretty significantly. You don't want to go back to like iOS 4 or before because things are going to be substantially different. So look for iOS 6 things. Another book that I've never actually looked at, but is supposedly also pretty good, is this one. And I added this slide just before, because this is the one I actually use just to catch myself up with everything. It's a free preview of a book, and I found it to be pretty good. I feel obligated to say, like he does at the top of the page, that if you found it useful, you might want to consider actually buying the book. But that pretty much everything is in here. Okay, so before we get into Objective-C, we first need to touch on C. So it's important to remember that Objective-C is a proper superset of regular C. So like any Objective-C program that you write, you could write valid C all throughout the Objective-C program. Well, not literally everywhere, but everything you know from C is still applicable in Objective-C. So first, show of hands, who knows C or any C? All right, that's better than I was anticipating. And another show of hands, who has any experience with any object-oriented language? All right, cool. So we'll do a really quick intro to C just to refresh you on everything. You'll probably recognize that a lot of it is pretty similar to JavaScript, so it's probably still pretty fresh. So your very standard hello world program. What does hash include standard.io.h do? What is standard.io.h? I think I might have heard someone say it, but it's a header file. It literally just contains like, we'll see like the declarations of the functions. So we'll see more examples of those later. Those are still going to be pretty important in Objective-C. Here we see we are declaring our main function. So just like in C we declare a main function, in Objective-C you are also going to have a main function. And what are these guys? Int argc and const char star argv. What are those? Command line arguments. So int argc is how many arguments were passed at the command line, and const char star argv are what those arguments were. And then we just printf. We'll see that once we get to Objective-C, we're not going to really be using printf anymore, but pretty standard program. So statements, that is a statement. Variables, you just declare them int n, or you could say int n equals 0. That's going to be the same when we get to Objective-C. We have all of our regular primitive data types, char, double, float, int, long, and then the modifiers like unsigned int and unsigned double, and printf. So if we, let's go into, we'll have a whole bunch of example programs up, and we have a whole bunch in C and Objective-C. We're not going to go through all of the C ones because a lot of them will just be tedious. But if you feel you need a refresher, you can just go back and look at all these. So we'll look at the first C one, hello C. Okay, so this is what we just saw before up there. And printf, remember, takes these modifiers, such as %s, that are going to then be a comma-separated list of things at the end of the printf call that you're going to fill in. So like %s, it's expecting a string to fill in that %s. And if instead we did int n equals 50, then we could do %d and pass in the variable n. So that's how we're going to use printf that's how we print variables. And you'll see that these format specifiers, this %s and this %d for integer, those are going to carry over into some Objective-C areas. Plus, all of these primitive data types, remember that Objective-C is a superset of C. These still exist. Yeah.
Can you show that link to the book, the internet book?
You
did it too fast.
The slide will be online later, but if you want to look it up now.
Thank you.
Yeah. And feel free to stop me at any point with questions. Good? Okay. Okay. So the Boolean expressions, the very simple ones that you should all be used to at this point. Conditions, we have our regular if-else's. Loops, we have for loops. So in JavaScript, you also have the for in. You'll also see that in Objective-C. Regular C does not have that. So we have our regular for loop, regular while loop, regular do while. And all of those will still be usable in Objective-C. So casting is an interesting case where it's exactly the same between C and Objective-C, but you're going to see you might be needing it a lot more once you get to Objective-C. So in C, there are only so many cases I can possibly think of where I want to cast. Like one example is if I want to do 3 divided by 5. You know how if we just do the integers, then 3 divided by 5 is going to be 0. So I might want to cast 3 to a float so that it actually does floating point division. So that's one scenario I can think of where I want to cast. Once we get to Objective-C and we start dealing with classes and things, then we're going to want to cast, we'll see more of this, but super types to subtypes and subtypes to super types. So casting, you'll want to be comfortable with it. And then pointers, they won't be as important in Objective-C, but you're still going to have to deal with them. So we have just the type of a pointer. Let's actually look just as an example. All right, we'll go over the typical example of a swap function. That here, so this line, like I hinted at before, this swap line is the function's prototype. So those are the sorts of things that we'll see in header files like standard.io.h. We'll also see struct definitions. We'll get to structs. We'll see hash-defined things. So here in main, we declare a variable x and a variable y, and then we print x, print y, and now we want to swap x and y. So ideally, after this swap line, x will have the value 1 and y will have the value 0. They will have swapped values. And I won't actually run it, but trust me when I say that this will not succeed. Looking at the actual swap function, we see it takes a and b, so we're passing x for a and y for b. We then store a in a temporary variable, put b into a, and put the original a into b. So why this doesn't work is it's important to remember that everything in C, when you pass it to a function, it's always a copy of the thing being passed. And so here, what we're actually passing to a swap is a copy of the value 0 and a copy of the value 1. And so down in the swap function, when we say a equals b, we're just modifying the copy of those values. We're not modifying the original x and y. So here's where pointers become important. So here, notice the function prototype has changed. We now are passing int star a. So as soon as you see int star or char star or anything star, you know you're dealing with a pointer. And coming down here, we're no longer passing x and y. We're passing ampersand x and ampersand y. So ampersand, I usually read literally as address of. So we're passing the address of x, and we're passing the address of y. And so, oh, and it's since x is an int, then when you get the address of an int, the type